So one thing I also wanted to outline for the previous question is that for integration of a function on a plot, what it's essentially doing on this plot, so some function f at x, the integral will be calculating the area underneath that function, so between the x-axis and below the function line or curve. So that's what it's essentially calculating. Okay, so on to the next question. What are the domain, range, and asymptote of the following function? So if we had the function g at x equals 0.5 power of x minus 9. So a domain is a function, or the domain of a function is the set of input values for which the function is real and defined. So in this scenario, for any x value that we substitute here, so 0, 1, 2, 3, 4, or negative 1, and so on, we would get a value for y. So here the domain is just all real set of numbers. So let's say the domain is all real set of all real numbers. The range or the asymptote, how we want to define this is we start off by rearranging the equation. So we'll say this is, so g at x is also equal to y. So we'll just erase this and we'll just say this is y for simpler notation. And we'll rearrange the function to get y plus 9 is 0.5 power of x. Take the log of both sides. So log y plus 9 equals x log 0.5. So we just move the exponent down to the front. That's one of the properties of logs. And then we isolate for x. So log y plus 9 over log 0.5. So the main reason we're doing this is to see if there's any asymptotes. So by solving for x, we've already solved for y up here, and we kind of can see that there's no asymptotes. And the range for x is all kind of real values. For y, however, we can see that for log, the property of log is that this value over here cannot be greater than, sorry, it has to be greater than 0. So y plus 9 has to be greater than 0. Because that's just a property of log, so this gives us kind of a limitation for this function. So y has to be greater than negative 9. And we know that that means that y equals negative 9, there's an asymptote. So y equals negative 9. So this is one of the asymptotes. And we know that this is kind of the range in the y-axis. So I believe there's a graph of what this looks like. So we can kind of see over here that when it reaches negative 9, there's no values below. So if we substitute y into this equation, we can't substitute anything equal to negative 9 or below, but we can substitute anything greater than negative 9. Similarly, for x, we can see on the graph, so any value of x here, there's a y value associated with it. So this would give us that for any x value, we get a y value. So here we can say that that an asymptote exists at y equals to negative 9, and the range for this function is y has to be greater than negative 9, and then x could be from negative infinity to positive infinity. And then the domain is just the set of all real numbers. So just looking at the solution now, as x tends to positive infinity, then y tends to negative 9. Hence y equals negative 9 is the only horizontal asymptote. So they go through a similar process for isolating for x to get that y equals negative 9 is an asymptote, and that y is greater than negative 9 is the range in the y for the function. So here the solution is correct. Great job.